Alright, so this is about the Littlewood-Offord problem in the plane and then in d dimensions, in any number of dimensions. So this is a whole subfield of mathematics, so this just looks at a small part of it. So what you do is you start with a multiset of vectors. So we're going to start in 2 dimensions. You can see these are in 2 dimensions. And a multiset is just like a set, except you can repeat things. So, this is the same thing repeated. But you start with a multiset of vectors, and then you do this plus this plus this. So if you do yellow plus blue plus red is that. But you can also do minus yellow minus blue minus red, and that's that. You can also do yellow plus blue minus red, and that's that sum. Okay, this is graphical vector addition. So in that way you get 8 sums, because you can do plus or minus for each of the 3 things. 3 to the power of 2 is 8. 2 to the power of 3 is 8. My goodness. So you have 8 possible sums, and then what you're interested in is how many of these sums are equal. In this case it happens to be 2. You can find 2 that are equal,
Okay.
but you can't find 3 that are equal. So you do 2 over 8, 1/4, 2/8, and that is called the maximal Littlewood-Offord probability of this set. Okay? So every multiset has a probability. The question is, if you restrict what kinds of multisets you want to consider, what's the highest probability you can get? And what are the multisets that give you that highest probability? So this project looked at that through, first of all, code. So I put in specific multisets, found their probabilities, because it's just adding stuff, right? So I found their probabilities pretty easily, and I graphed some of them here to just get an idea. Then I looked at past research to get an idea of how this is in the plane, how this is in higher dimensions, and then based on all of this, my mentor and I came up with 2 proofs and 1 conjecture. That can
Conjecture indeed.
So that's for future work.
Where's the conjecture?
This is the conjecture. So the conjecture relates the case in d dimensions to the case in 1 dimension. So the conjecture says, suppose you have some vectors in d dimensions. What we do is we project so let's just say 2 dimensions, right? You take some in 2 dimensions, and you project them down to the x-axis, you'll get some points. That's one multiset.
Okay.
Then you project them to the y-axis, you get some points. That's another multiset.
Okay.
Each of those has a maximal probability. So this conjecture and this proof, this is like a weaker version of the conjecture, the one that I proved.
Okay.
Those relate the probabilities that my mentor and I proved. Those relate the probabilities in the 1-dimensional cases to the probabilities in the 2-dimensional cases, or actually the d-dimensional cases.
The d-dimensional is a conjecture.
No, so there's 1 d-dimensional that is a conjecture and 1 d-dimensional that is a proof.
I see.
Yeah. The d-dimensional that is a proof is a weaker version. The conjecture is a stronger version.
Okay.
So that's this project.
I don't have a conjecture all my life.
Maybe you already proved everything.
Or disproved it.
Or disproved it. That's good too. Disproving things is very good.
Okay, yeah. Once you have a conjecture, you can either prove or disprove it, I guess.
Yep.
Okay, and then you can devote the rest of your life trying to do that one.
Probably won't take that long. I don't know. We'll see.
Okay.
Hope not.
All right. Good luck with and Moksha is your.
And all the thanks
guy.
go to Moksha, who is amazing and
Okay.
awesome and wonderful.